In this lesson, we're going to be going over more detailed use of Wireshark, specifically how you would use it to do some deep analysis of things that were going on your network. So Wireshark has some really useful network analysis tools. Up top here, you can see a lot of different menu items, and we're going to go right to left and talk about some of the things that Wireshark has to offer. The first one we're going to talk about is telephony. In this case, we're talking about voice over IP. So we're talking about SIP and RTP and H.323, voice over IP primarily, data calls. Wireshark will show you some statistics about your voice calls. And in this particular capture, I don't have any voice calls, but I can show you what the menu item looks like or what the dialog box looks like. So in this case, you'll see it says detected 0 VoIP calls and selected 0 calls. If there were calls, you could see the start time, the stop time, who the initial speaker was, who it's from and to, the protocol being used, the number of packets, and the current state as seen by Wireshark. If you were to have a call here and you were to select it, Wireshark could show you statistics about the call like jitter and latency and those sorts of things. So Wireshark is good about pulling up statistics about voice calls. The other thing that Wireshark can do, it can play the voice portion of the call. So you see here player, and it says launch the RTP player to listen to the selected calls. If the voice stream is not encrypted, if it's just a clear text stream, Wireshark can decode the RTP messages and play them back for you. It can also show you a flow diagram or a ladder diagram of the selected calls, so it can show you all of the signaling messages for VoIP calls and broken down in order, which is really helpful if you're doing troubleshooting for voice calls or VoIP calls. In addition to telephony, of course, it does all of the standard data stuff that you would expect it to do. So under the statistics menu item, we've got a lot of interesting things here. We can bring up endpoints, for example, and it will show you all of the different endpoints that are involved in this particular packet capture. In this case, it's selecting them by Ethernet. I can also select them by IPv4. So these are all of the IP addresses that have been seen in this particular packet capture. There's also some IPv6 addresses. And then we've got higher level protocols like TCP and UDP, so it's broken down by these as well. Going back to the Ethernet here, you can see how it's broken down. We've got the address, and it's got the packet count and the byte count, but it also breaks those down into transmit packets and bytes and received packets and bytes. So this is really helpful in order to do some diagnosis on what's going on in your network, where you can see either by Ethernet address or MAC address or by IP address the different endpoints that are doing communications in a particular packet capture. I've also got conversations, which is a similar sort of thing. It will show you the conversations that are going on. The dialogue looks very much the same as the endpoints. We've got I/O graphs, where you can do different things. You can set bytes per tick and bits per tick, and you can add colors, and you can put together a little I/O graph of the network traffic that you've captured. We can also do a flow graph. In this case, I'm going to select all packets, and I'm going to do a general flow with standard source and destination addresses. And it's going to show me, this is very similar to the ladder diagram that I mentioned earlier with regards to VoIP calls. You can see the ladder here where the endpoints are involved in a particular dialogue and who's actually said what and to whom they said it. And on the right-hand side, the comments, so you can see the information about the packet. It's TLS, it's TCP, it's HTTPS. So this is really helpful for getting a visual understanding of the different conversations that are going on and what they're actually saying. It's easier sometimes to see it in this respect than it is to just look at a list of numbers and so on in a Wireshark capture. Under statistics, you can also pull down different things like HTTP. I can get the number of requests. If I were to set up a filter, I could get a statistic on that. I can get statistics on a TCP stream graph, round trip time graph. If there were wireless traffic, I could see that under WLAN traffic. I don't happen to have any here, so it's not going to show it. Moving along to the Analyze menu, you can see the list of enabled protocols here, and it's pretty significant. Wireshark has done a really good job over a lot of years of really beefing up what they're capable of doing. And if there's new protocols that get added, Wireshark is pretty good at picking up on those. Something else that's good here is decode as. If you were to see a stream that was taking place on oddball ports, for example, web traffic on port 8908, for example, Wireshark probably won't recognize that that's web traffic because it's on an oddball port and it may not see that that's really what's going on. It might, but if it doesn't, you can do a decode as. And you can say, instead of what you've currently decoded it as, you can decode it as this other protocol. So I want to decode it as HTTP. In this case, it's already done what it can because I happen to have an encrypted packet selected. But you can see that if you've got a particular traffic stream that Wireshark isn't doing the right decoding for it and showing you the right information, you can tell Wireshark to go decode it as a different protocol, and it will reorganize itself and show you all of the right information. So like down here, when you open it up, in this case, I've just got TCP. If I were to find an HTTP packet, you can see that Wireshark down below here, it's got TCP and it's also got HTTP. So that's partly where the decode helps you. It puts that extra section down below and properly analyzes it so all of the right pieces are filled in. While we've got this open, let's select this packet here. I can do Analyze and Follow TCP Stream. One of the advantages of Follow TCP Stream is you don't have to open each individual packet up and take a look at what's going on and the ASCII that's inside it to be able to see all of this. What Follow TCP Stream does is it follows it and then puts an ASCII equivalent or a text equivalent up here in a box so you can just read it in plain text. This is a really helpful feature. I can also change this. In this case, it's raw. I can change what I'm doing to ASCII or EBCDIC. In this case, it's not EBCDIC. I can get a hex dump of it, and then I can also show C arrays. So you see the character array definition here. So I can break this into different pieces. I can also say I only want to see this half of it, or I only want to see this half of it. If you've got a really long conversation, maybe you only want to see one side. So as you can see here, Wireshark has a lot of really useful features for deep packet inspection and analysis.